Good morning, good afternoon to everyone. Thanks for joining us in today's session on Seize the AI Moment. Hopefully this session will be a very useful and informative for all of you today. Just to quickly run through the agenda. So this session should be about 90 minutes. And we have sufficient time at the end for Q&A as well. We'll have the opening by our CEO of Juniper Networks, Rami. He's going to kick off this session. And then follow next is a discussion on Ethernet versus InfiniBand. And it's a discussion with Broadcom and ACG Research. I think this is a question that I get quite a fair bit from customers that I've engaged with on AI clusters in AI networking. Then there'll be a panel on the AI ML ecosystem and trends with Cerebrus, AMD, Intel, and Weka storage. This should be also a very interesting session, to showcase the different partners and players in this technology. Then followed by a discussion on AI training, inference, and performance with ML Commons. ML Commons is basically an organization, and they have a website that actually holds training results. They try to actually provide a standard kind of platform and benchmarking for not just like language training or large language training, but also on infrastructure performances. So that's where ML Commons come in, very useful. And also Meta AI is also there. I think this is also very interesting to hear from Meta how they actually train their models, with Ethernet. And then finally, there's a discussion on Ops for AI, something that Juniper Networks we announced recently, and also introducing the Juniper's AI lab in Sunnyvale. Right? Then I'll summarize after the session. We have a Q&A as well. Then after that, I will close today's webinar. For the Q&A session, just a reminder, please use the Q&A box. Don't use the chat box, right? So at least we can see all the questions. We can list them. And also, if there are questions that if we cannot, either due to time or whatever reason that we can't get back to you, we'll make sure we get them to you individually, as long as your email address is there. All right. So without further ado, let's kick off the session.
We're so glad you're here to join us for an exciting lineup of speakers on the future of networking for the data center. You know this. We're living in the era of AI, and it is transforming all aspects of your technology and your business. For technologists like me, it feels like we're seeing the future unfold before our eyes, and it's incredibly exciting. The pace of advancement and growth in the three critical ingredients of AI is simply breathtaking. We're seeing massive scale in AI models, in the data that's being used to train AI, and in the computing infrastructure that makes it all possible. Which means your AI data center infrastructure is growing at an unprecedented rate. Dell'Oro Group estimates that AI application traffic is growing by a factor of 10, and AI cluster size by 4 times every 2 years. There is rapid innovation at every layer of the stack, and you're faced with keeping up with that incredible pace of change, all while managing the immense power needs of AI. Nonprofit energy research organization EPRI says in a new study this year that AI queries require approximately 10 times the electricity of traditional internet searches, and generation of original music, photos, and videos obviously requires far more. With these intense energy requirements, data centers could consume up to 9% of US electricity generation by 2030, more than double the amount currently used. Clearly, you need a partner who knows what they're doing to help you on your AI journey. And Juniper is that partner. We're not new to AI when it comes to understanding the awesome power of AI in solving the pressing IT problems of today. Nobody has more experience than we do. We built the industry's most comprehensive AI-native networking platform that's transformed the experience of networking for both end users and operators. With our AI-native insights and automated actions, the Gap reduced their site visits by 85%, and Dartmouth College reduced their time to deploy infrastructure by a factor of 9. As proof of our market traction, look no further than the success of our campus and branch business. Mystified revenue, including all products driven by Mist AI, grew nearly 70% in 2023. That success does not come by accident. So again, we understand the awesome potential of AI simply because we've been tapping into it for years and seeing great success as a result. But this event is about the stuff that makes AI possible to begin with, the infrastructure stack that makes it all a reality. It's what we call networking for AI, and this is an area where we've been investing heavily and seeing some real momentum. In fact, we're the first branded networking vendor to launch an 800 gig E-switch based on the Broadcom Tomahawk 5 chip. Our new PTX 10002 leverages our own Express 5 silicon to achieve industry-leading performance and power efficiency for the AI data center spine and interconnect. And we've built innovative new congestion management features for AI into the industry's most advanced data center fabric management and automation solution, Abstra. Through our own testing in our Ops AI lab, we've demonstrated that Ethernet performance is on par with InfiniBand for tough AI training use cases, and we've shown that Ethernet is far more economical. It is no wonder that our AI data center customer wins are ramping up rapidly. The University of Wyoming, Deutsche Bahn, and AI supercomputing company Cerebras have all signed on, just to name a few. We're also working with social media companies and AI as a service companies, which need the tremendous networking and compute power that large language models require. AI has the potential of being as big, if not much bigger, than the internet. The market opportunity is immense. To win, we can't just make incremental moves. We all must take bold actions. We believe that for AI cluster infrastructure to move from early adopter stage to mass market, the industry must coalesce around open technologies to harness the collective power and innovation of an ecosystem. And this is why we're here today. With Juniper, you can make every connection count. Thank you for joining us.
Some great insights on use cases and the future tech trends on innovation, especially around power. Bob, power is huge.
Yeah, absolutely. You know, we're going to need organizations to drive much greater efficiency if we're going to be able to have sustainable data centers for AI use cases.
And all the improvements are critical to have power. Coming up next, Mansoor Karam, GVP of Products and Data Center at Juniper, sits down with Broadcom's Ram Velaga and Ray Moda of ACG Research to dig deeper into the economics and the performance of Ethernet networking for AI.
Yeah, I'm looking forward to this one. I want to see if they think this will become the, Ethernet will become the de facto standard for all these AI clusters.
Before we dive in, tell us a bit about yourself, guys. Let's start with you, Ram.
My name is Ram Velaga. I run the switching and routing Ethernet business at Broadcom. And the last couple of years, I've really been fighting the Ethernet versus InfiniBand battle.
Excellent. Ray?
I'm Ray Moda. I'm CEO and principal analyst for ACG, and we focus primarily on the service provider space and the large enterprise, doing a lot of work on research, but economic modeling as well. Ethernet, it's been a hot topic lately.
It has indeed. So let's jump right in. Ram, I'm going to start with you. At your most recent AI virtual event, you talked about InfiniBand versus Ethernet, but I think you really set the context properly by talking about the importance of the network, especially in today's AI clusters and AI workloads and AI applications. Can you tell us a bit about that?
Yeah, sure. If you think about AI, right, in the first thing you have to think about is it's a distributed computing problem. And what I mean by a distributed computing problem is you cannot take an AI workload and run it on one GPU, no matter how big your GPU is. Somebody today can come and say they have the fastest GPU. 2 years from now, they can come and say they have something that's even faster. But the reality is any particular GPU or accelerator is only as big as what a TSMC can build, or advanced packaging that you can do, or the fastest HBM you can put on. But really what you need for a machine learning or an AI workload is many tens of thousands of these GPUs all acting together as if they're one very, very large computer, right? To do that, you really have all of these to be tied together, and all of these have to be networked together.
Right.
And that's what we mean by, this is a distributed computing problem. When you have a distributed computing problem, the network is what ties all of this together, and the network becomes the computer.
Right.
Because anyone can build the fastest GPU, but if they cannot tie all of these GPUs together to act as if they're one large piece of single computer, the whole thing falls apart. And that's what we mean by the network is the computer. And if network is the computer and you want to build the best network that's out there, there's nothing like Ethernet.
There was a finding from Meta, which I thought was really insightful, that you highlighted in your talk. Can you tell us what that finding was about how the network is critical for making sure that these GPUs don't stay idle?
So I don't know if you've seen this presentation, which was presented by Meta, I believe about a couple of years ago at the OCP. And what they showed is different workloads that they had, different kinds of recommendation models that they had, and how much time was spent in the network, the traffic going back and forth between these GPUs. And it varied anywhere from 20% to almost 57%.
Right.
What it means is there is that much amount of time, somewhere between 20 to 50, almost 60% of the time, the GPUs are sitting idle, waiting for the traffic to be shuffled between these different GPUs, right? Now, so think about it. Typically, these GPUs probably sell between $20,000 to $30,000, depending on how favorite a customer you are
Sometimes
of the
more.
vendor.
Sometimes more, a lot more.
Now, and then you take those and you're now putting together 100,000 of this. You do the math. That's anywhere between $2 to $3+ billion in GPUs.
Right.
And if these things are sitting idle, that's a pretty expensive affair.
We're talking about $1 billion, right? Like
No,
50%.
Yeah, so if you say 50% of the time you're sitting idle, you're sitting, about $1.5 billion sitting idle there.
Yeah. And in that same study, Meta actually, they built two different clusters, one with Ethernet, and we can talk about now Ethernet versus InfiniBand.
Look, I think, 2 years ago, if you talk to anybody, they said, if you're building a GPU, cluster, AI machine learning, nothing other than InfiniBand will work.
Right, I remember. Yeah.
Right? Because everywhere you went, it's like, if it's not InfiniBand, this is not going to work. And I was sitting there scratching my head saying, that's not true, right? Today, when you look at it, top seven out of the top 8 largest clusters in the world are built based on Ethernet.
Yep.
There is one last remaining one that's built on, InfiniBand, but my take is, in a year and a half from now, that will also be based on Ethernet. Okay. So what's happened over this 2-year period is, initially when you get a solution that's kind of all purpose built by the vendor and that says, okay, look, you cannot touch any of this. You've got the GPU, you've got the NIC, you've got these cables, and you've got the switches, and all of this is pre-engineered by us. If you touch it, the thing is not going to work. There is a lot of fear, uncertainty, and doubt based on which the customers who are in a rush to deploy these systems will just take it as somebody is giving it to them, right? But then as customers start to deploy them, they'll start to find out, look, operationally, InfiniBand is very different than Ethernet. Number two, it has a tendency to just literally, break down quite a bit more than just Ethernet has been built for, because Ethernet is built under the notion that it is going to be very scalable, reliable, and so on and so forth. So customers have gone through these experiences and said, look, I have to actually benchmark InfiniBand versus Ethernet to see if it is worth this hassle of maintaining this InfiniBand, which is very, fragile. Right? And they started to test, and Meta put out this paper. They did over 24,000 plus GPUs, and they tested them both, and they found out Ethernet was pretty good. It was actually in many cases very comparable performance to InfiniBand, but with the operational ease and reliability that you expect out of Ethernet. So there's more and more benchmarks that have been done across the industry, and that's why the industry has moved on to Ethernet.
Yeah, and I think there's history here too. In the past, I mentioned when I was a former CTO, I loved ATM technology because you can slice and dice the data. We had triple play back then, but I remember designing trading floors and stuff like that. And my boss came over and said, I want you to try these broker workstations with Ethernet. I'm like, Ethernet? Are you kidding me? We have ATM
and we make a lot
anywhere
of money.
like that, right? But then our CFO came in, hey, it's $1,200 a NIC car for an ATM 25 meg, and it's $69 for 100 meg.
At price.
Right. And I was like, so I learned the economics part of network design, but initially I was concerned about the architecture of Ethernet, but it just kept getting better speeds and that efficiency. So I learned early on never to bet against Ethernet from that perspective.
Right. The ubiquity of Ethernet.
Yeah, the ubiquity
makes
is
it.
there.
So from an economic standpoint, maybe do you want to comment a bit more? I know that you did a study recently, right, of the economics of Ethernet.
And for those who don't know, what we do is we have a software platform that's kind of like a digital twin, but it does economic simulation modeling of whatever architecture versus any architecture, any technology versus any technology or any use case or application for that perspective. So what we did in this particular case was we model Ethernet against InfiniBand, and then we use a similar architecture where we use spine leaf technologies, and we had a server environment where we had the DGX8, I think the H100s, and from that perspective, we had the server environment, but then we had a compute network that we had InfiniBand, but then we had, in this case, the Juniper, the QFX switches from that, and then the interconnections range between 400 to 800 gig. And honestly, some of the findings from a CapEx perspective is about 55%, because even the ports on InfiniBand itself are twice as expensive as an Ethernet
So
port.
50% cheaper for Ethernet compared to InfiniBand.
Yes, 50%
so
cheaper.
less than half the cost.
And then when we looked at some of the other parts from the switching costs, then we looked at the equipment costs, which a lot of people forget, cables, optics, that adds up over time, and there's different requirements. And then the second part is the OpEx.
Right.
How much does it cost to manage this environment? And this is where we model, intent-based automation with Abstract to say, how do we simplify? So the overall TCO came out to about 56% savings over a 3-year time frame right now.
Wow. So we're talking about same performance, better reliability, and more than half the cost. But then to get to performance, I think that another also critical factor is management, right? Debuggability, observability, right? In the ecosystem of tools, right? Knowing what's going wrong in the cluster or fine-tuning a cluster to make sure that the parameters are all set properly from a networking standpoint is also very important. Knowing what's going on the link, on the wire is important. Right. And for Ethernet, there are hundreds and thousands of tools out there. Of course, we built one, Abstra, now part of Juniper, which works across all types of vendors. But there are many such tools on the market. Yeah. I suspect that that's also a factor compared to InfiniBand. I don't know how many tools there are to go and debug or provide observability into InfiniBand. I suspect that was a factor in your study.
That was a major factor. We focus mostly on tangible benefits, but there's a lot of intangible benefits associated with it, where when there's only one vendor, you're at the mercy of their timeline and their priorities, not yours, right? So that's a challenge, right? The other part is the number of skill sets that are available out there to be able to support something that's set up this way and stuff like that. Where if you look at, I talked about just the cost of the equipment, look at the cost of the skill sets that you have to acquire. You normally, when you interview an engineer, you don't ask if they have Ethernet skills,
Yeah.
right? So I think those are the intangibles that people aren't thinking about. How much is it to the skill sets to maintain? Because that adds up to operational costs. And more importantly, I'm more concerned about business continuity. Because realize we're talking about AI, but some of these models could be used for high performance computing or whatever parallel processing that requires that type of environment and stuff like that. So there's a variety of use cases on top of AI for that.
Yeah, I mean, I can imagine that an organization has multiple networks,
multiple
and
networks,
the more commonality there are in these networks, the better in terms of leveraging the workforce,
Correct,
the
yeah.
expertise. Also, there are some security aspects, right, Ram?
Yeah, so let's talk about security, right? So for example, now specifically when you think about AI coming into the enterprises, what do enterprises have that's really differentiated? That is their own customer data, their own analytics, how their whole business runs, and a lot of that is very proprietary. And some of it is so fundamental that they're not necessarily maybe going to feel very comfortable putting it outside their own premise. Now, so they start to build their, private AI cloud, so to say. When they start building it, what needs to happen is there's a lot of data that goes back and forth between what is stored in their cold storage, active storage, and into these GPUs, doing the data analysis, crunching out some, coefficients, and then pushing it out. So what this means is it has to come into the natural security policies you have already inside your enterprise and how things are being stored, secured, who do you give access to what, so on and so forth. So if you build something with something like InfiniBand, which doesn't have this notion of access controls, security, and so on and so forth, you're going to be building completely different islands. And the whole idea of building something that's private, into your enterprise and moving data back and forth is not going to work.
Right.
Which is where kind of having everything on Ethernet, one common fabric, one common set of policies, one common set of access controls, right? Just makes all of this so much more easy.
I was going to
It's an
say,
intangible,
I'm
right?
actually glad you brought that up because not enough people are talking about the security aspects of it, because I always say security is as strong as your weakest link, right? And then having the more distributed you have security, the harder it is to manage and more opportunities for penetration. And you don't want to have these dead pockets where people don't have understanding of what's going on in that area. So I always say no security, no business.
Excellent. We've said that Ethernet provides similar performance than InfiniBand. Maybe tell us about UEC. There is an effort, right? I think it's about improving the scalability of RDMA specifically, right?
Yeah.
Do you want to tell us maybe a bit about, the purpose for UEC and how it's going to scale Ethernet to even further?
So while Ethernet today does everything that InfiniBand does, toe-to-toe, can go in, better performance, much higher reliability, less than half the cost, we're all kind of thinking ahead about how do you improve RDMA, not Ethernet, but how do you improve RDMA? And that's where UEC has come up with a bunch of improvements to RDMA that allow it to do multipathing. So you don't assume there's just one path between point A and point B, that there's multiple paths. Then you have efficient, retransmits, which is if packet 4 got dropped, but 5, 6, and 7 got transmitted, we will go back and only retransmit packet 4 rather than transmitting 5, 6, and 7. So it's built under the assumption that your underlying fabric might actually fail, rather than InfiniBand and RDMA that said underlying fabric will not fail, right? So you build resiliency, knowing failures will happen. Otherwise, it's like, hey, building in, a skyscraper in San Francisco saying there will be no earthquake, right? That's a ridiculous assumption to make.
Right.
Assume there's earthquakes and retrofit the buildings. And that's what, is
excellent. And there is going to be a large ecosystem around it and multiple topology options, right? Like where you can involve the NIC or you may just work within the confines of the switches, correct?
Exactly.
Yeah. Excellent. All right, gentlemen, that was insightful and lots of fun. Thank you very much.
Excellent. Always valuable to hear from the early adopters and learn from them. Thanks for sharing your stories. What'd you think, Bob?
Yeah, I thought it was great. I mean, anytime that you have an opportunity to learn from organizations that have gone before to get past those obstacles that are unforeseen is always going to be advantageous.
Certainly, if you're tuning in today, you probably heard of a little company called NVIDIA. They deliver tightly integrated AI solutions, but some recent changes in the industry have opened the door to a full multi-vendor ecosystem of AI clusters. To lead us through that discussion, I'll hand it over to Raj Yavatkar, Juniper's CTO.
I'm really excited for diving into a discussion about AI ecosystem and accelerators. Joining me today are panelists from some of the most innovative companies in the world, starting with Andrew Feldman, CEO or co-founder of Cerebras Systems, Justin Hottard, Executive Vice President and General Manager of AI and Data Center Business at Intel, Steve Scott, Corporate Fellow, heading the Networking and System Architecture at AMD, and Shimon Ben David, CTO of Weka. What were the things you were hearing from the customers or industry with respect to this revolution that we are witnessing? What did you hear about? What are the requirements that came to your mind that got you embarked on this particular journey?
In fall of 2015, and AI was very much on the horizon and not yet close by. There was a lot of work done in vision, in the computer vision category, but this was long before large language models emerged. First, what the founders wrote on the whiteboard was that we wanted to work together again, and that we wanted to do something important. That we wanted to try and move an entire industry. And as we began to explore different problems, the challenges that AI presented were interesting to us. We observed that it wasn't obvious to us that a machine built for pushing pixels to a monitor, right, which is what a graphics processing unit was designed for, it wasn't obvious to us why that would be good at AI. And that we thought that there would be an opportunity to build a dedicated machine optimized for AI. And we thought for sure that we could build a better machine than a wide vector SIMD processor with limited memory bandwidth, which is the family of that the graphics processing unit lives in. We spoke to dozens of customers. Everybody was having trouble with training times. It was the limiting factor, and it remains to this day the limiting factor on iteration time. We've added some new limiting factors: how long it takes to set up graphics processing units, how long it takes to distribute a model over a large number of GPUs. And it turns out that the chosen path that we embarked on turned out to be very, very good at those.
So I wanted to ask you, what's your take on customers' point of view? What are customers asking for when it comes to machine learning and AI workloads and system architecture and systems in general?
Sure. Well, I mean, mostly AI is just driving a huge appetite for performance. You know, everybody's constrained by budgets and space and power. The colo rates are historically low, like less than 2%. I've heard that over 80% of new data centers that are under construction are already leased. So one of the things that customers are asking us about or talking to us about is just the need to consolidate their general purpose compute to make up space, free up space and power for AI. So a lot of our AI interest is actually on the EPYC side, with people using EPYC CPUs to consolidate their older servers. Because they're very power efficient, and people are seeing like a 5 to 8x consolidation possible with from older servers. And then for the AI infrastructure itself, people are just looking for choice and flexibility and competition. They obviously want better price performance for training, but especially for inference, which is really the larger part of the market. And most of the inference is done on CPUs, but the high-end inference is all being done on GPUs, and we're pretty consistently hearing that people are looking for a second source for their accelerators, and so a lot of interest in the AMD Instinct 300X. I think over 80% of enterprises now are deploying generative AI models that have been optimized for the 300X. So that's been a great success story for us.
When I look at the infrastructure for the AI data centers, the three sort of legs of the infrastructure: compute, networking, of course, that we come from, and storage or data platform that you guys provide. So I think I would really like to start by asking you, what's your take on, the role that a data platform or storage plays in ML data centers?
So I think there's this conception that obviously AI, ML, definitely Gen AI requires massive amounts of data, and that's definitely true. Yeah. More than that, if we're looking at the different stages of the pipeline between that exist in AI and Gen AI, a lot of them are very storage oriented. So definitely accumulating massive amounts of data. You need allocation, a cost-effective capacity environment that can accommodate the protocol of the ingestion of the data, but also the scale of the data ingested. And this could be from worldwide fleets of data. This could be data brokers. This could be HPC simulation data created. So you need to be able to accommodate for it. Then the different stages of data are more or less intensive. And the interesting thing is that every stage has its own I/O pattern. Maybe I'll summarize with there's massive requirements for storage or data environments in AI that behave completely different than traditional enterprise storage or traditional HPC storage. It's a new thing completely.
One of the things I wanted to learn from you is that what are the things you hear from customers with respect to requirements as we are sort of going very strong with machine learning training, inferencing, those workloads are becoming very important.
I think this has been an incredible journey, right? AI, you're right. A few years ago, we were talking about AI in HPC and supercomputing as an emerging workload, and of course, with the advent of ChatGPT, all of a sudden it became the dominant workload, and now we're building supercomputers all over. And I think that probably gets to some of the challenges. I think first of all, one of the biggest challenges in this space for customers is data center capacity, power, the CapEx, the compute intensity. I mean, the level of investment in this space, and we've obviously seen it explode. And I think while everybody is eager to get on board and start to use Gen AI, it's the reality is it's a big investment, and that's why one of the things we're doing at Intel is trying to provide lower cost access points, things like our developer cloud, where we can give access to customers to get started, to learn, to test some of the ideas and tools that they have. The second thing I would say is it's really all about leveraging the data that enterprises have. Over 80% of the world's data is in enterprises. The majority of it's proprietary. Compute has generated so much data over the last few decades, the advent of mobile and the internet and cloud, of course. But now we're talking about how do we unlock that data to generate new services, new insights, new sources of productivity. And I think that one of the things that we're seeing with use cases like RAG emerging as a potential enterprise use case is we need practical applications of data that recognize some of the foundational elements of data sovereignty, data locality, data gravity.
I would like to come back to the data and storage, but since you also mentioned a lot of data being on-prem and on-prem infrastructure where people are making lots of investments, given the current focus on these vertically integrated proprietary systems, I want to get your thoughts on where you think industry should go or trying to go.
Yeah, I mean, I think first of all, we're veterans of the industry. We've always seen that technology adoption often requires a proprietary stack to start, but we also know open ecosystems win out over time. And I think even if you look at where we are in AI today, whether it's OCP, the big drive around OCP standards, everything from the boards we're designing, the modules we're designing, obviously PCIe cards, a longtime standard in the computing infrastructure, at the core hardware level to the networking interfaces, UEC for scale out, UA Link, which we're a part of for scale up, the software interfaces, PyTorch, OpenAI's Triton, the advent of open models. I think the industry is pretty clear, right? And when you look across the industry, everybody wants open interoperable systems, open interoperable platforms, because we know over time that's where most of the innovation will reside. And most importantly, it allows end customers, enterprises, to innovate in the manners that are most relevant for them.
So as you look at the end user and end user applications, they need the whole stack, right? It's not just chip, it's not just a system, there's a whole bunch of software and tools and so on. So what is your view of how do you deliver the entire stack and what does it take? And do you use an open ecosystem versus a closed system? I have a bunch of questions on that.
Like you guys at Juniper, we're system builders. And that means we build chips and we build systems, printed circuit boards. We deliver the cooling, the power, the I/O to the chip. We package it in an enclosure, and then we run the equivalent of the OS on it. And in our case, it was a compiler. I think the industry did us a huge favor in consolidating. One of the real worries we had at the beginning when there was Cafe and TensorFlow and PyTorch and all these other things was how are we going to support all these languages? And right now, most work done in the industry is done in PyTorch. And that was a huge help. You know, we wanted to be sure that we bolted on to the ecosystem in exactly the same way you wrote models for competitive products, for GPUs. You don't need a special switch. We use standard Ethernet to communicate. All right. And this is obviously where you guys are strong. You don't need a particular NIC. All of that was so that we could move in the ecosystem without extensive sort of insertion force. And the result is a system that everybody writes to in PyTorch. And they can use the exact same PyTorch that they used on their GPUs. Only it runs faster.
Since you mentioned Ethernet, I'm going to jump into that. Traditionally people have looked at it from storage side. InfiniBand was the storage networking choice, and people are bringing it into AI, ML. But as you mentioned, Ethernet is probably the widely adopted, very scalable technology. So how do you see networking requirements in the world you live in?
I think we are building supercomputers to the tune of 20 plus exaflops a machine. And they include hundreds of our systems. And the bisection bandwidth of the cluster is enormous. We use Ethernet. We use 800 gigabit Ethernet, and we believe it's the ideal solution. I think I spent the first 15 years of my career in the networking industry, and I think Ethernet is a dominant force, and everything that has tried to stand up against it has been rolled over and crushed, right? Those of us who are a little older, we remember FDDI, and we remember Token Ring, and we remember AppleTalk, and we remember DECNES, and we remember all this stuff that just got bulldozed. The community has worked together as an ecosystem really well and sort of a model for others to develop standards so that we can interconnect. And I think betting against Ethernet has been a very bad bet for 30 years.
I think your brother was also involved in that, if I remember correctly.
When I was thinner and you had hair and the world was a little bit different. No, I think that's right. We look back at some of the things, and yeah, that was a really fun time to be in networking. The mid to late 90s were an extraordinary time, sort of like now in AI.
That's
where
right.
Inventions the field was rife with inventions. People were trying different things, and now we've made Ethernet transport and communication approximately free, so that other people with good ideas could build WhatsApp and 100 other things, and really change the world.
Yeah.
And I think Juniper and many other companies along the way played an important role in that.
There's a huge bunch of stuff has to come together. Question is the open ecosystem ready for that? Is it going to be able to deliver truly interoperable system architecture, which allows us to still optimize at every layer so that overall you get the power, efficiency, and performance you get needed for these workloads?
So I spent much of my career at Cray, and I think I architected 8 different generations of networks. And the first 7 of them were all proprietary networks because Ethernet was not high performance, so we built dedicated supercomputer networks. And then Cray realized back in, say 2015, that supercomputing was becoming increasingly data-driven. Ethernet was the de facto standard for data center communication. So rather than making another alternative to Ethernet, they could just make Ethernet networks as scalable and performant as their supercomputing networks were, and that's really what begat the Slingshot high performance Ethernet solution. And then today we also see Google and Amazon developing their own Ethernet extensions to run some of the largest clusters in the world. And then InfiniBand, which started as an open ecosystem, has ended up becoming a proprietary single vendor network. So now we've got this community effort with Ultra Ethernet Consortium to make Ethernet the absolute best option for large-scale AI and HPC systems, but do it in an open and collaborative manner and have that interoperability that you mentioned. And it's going to end up being a more modern and scalable network than InfiniBand is. It will implement packet spraying for really effective load balancing. It will implement selective retransmission on transient errors, which is much more efficient at scale. It'll implement much more effective congestion control mechanisms, etc. And then at the same time, leverage this huge Ethernet ecosystem. So you get more competition, you get more innovation, and it's much more cost effective. The NICs, the switches, the cables are like half the cost of InfiniBand. You get a much more robust supply chain. So overall, I actually expect Ethernet is going to provide better scaling and performance and much better price performance. The biggest challenge there is really going to be about building these very, very large AI systems and around management at scale. When you start talking about incredibly large systems, you'll have to deal with constant hardware failures. And so all the UEC work around telemetry and load balancing and congestion control and security, I think, will be particularly important.
Now, when I look at RAG plus inferencing, looks like this is a very different kind of a challenge when it comes to storage and even networking. So I want to get your thoughts on what is this so specific about RAG plus inferencing that touches upon storage requirements?
Great question. So maybe I'll start by explaining what RAG is. RAG, retrieval augmentation. So eventually when training a model, the model is aware of the data that it was trained on. So you can query, you can answer, it can do things on the data that it was trained on. However, organizations being dynamic, for example, if I trained an insurance model on my current regulations, maybe tomorrow I have new regulations added. And that's usually the case. You constantly have new data coming into your organization. So in the past, one thought was, let's retune the model constantly. Retuning is much more effective than training, but it's still a heavy operation. So there's this notion of let's point the model to my existing data. So let's retrieve the data and augment my model with my existing data. The way to do it, if you're looking at that, it's actually broken into different stages. You usually are running another model that goes over your company data and summarize it and throws it into a vector database. But there's this notion of I'm running a model, I'm running something across all of my company data. So maybe I have millions or billions of files, as is the case in a lot of organizations. And now I need to run something periodically that scans them or scan only new documents and converts them into vectors to throw into my vector database. And these vector databases also increase in size. So there's two types of storage requirements here. How fast can I run across all of my data environment in my organization? And then how fast can I push it into a vector database, which eventually will be translated into how fast my LLM can inference on the data, because it will get the data from the vector database. We're seeing customers that are maybe embedding once a day or even less, or even once every few days. So the implication is that when they're questioning their model, the model always has a drift of at least a day on the data set, while imagine a high performance storage, for example, Weka, that allows massive metadata and data operations, where you could embed much more periodically, every hour, every several hours, then your model suddenly is much more closer to your source of truth. So RAGing is very important. It does have its own storage requirements.
But how about the software ecosystem, right? Because you have PyTorch, we have your OpenVINO. There are pieces there, but you see all of these pieces coming together from software ecosystem perspective, because there are tools, there are SDKs, lots of things have to come together.
I think we're gonna, I think today we're in a world where there's obviously PyTorch has kind of become the standard framework. There's a bunch of other frameworks, whether it's VLLM for model serving. There's the push is going to be towards more and more open standards. I think what OpenAI is pushing with Triton, has really led the charge around the full stack capability for developers to really customize and optimize performance. Tune their models at very low levels for training. We're hearing that from customers. Customers don't want to deal with the lift of trying to support one proprietary stack to another proprietary stack, especially customers that are looking at large scale investments. I would say, there's always a place for proprietary tools that are also, of course, open source in nature, so that customers can modify and tweak them. You mentioned OpenVINO. It's a great example. It's an open source tool.
Final question I have for you is that what is next for AMD? Where is AMD going to go?
Obviously AMD is very, very interested in the AI market. We're focused on customer requirements and execution, but we have a very broad approach to the AI market. We have a rich portfolio from AI PCs. There's an incredible amount of interest now in AI PCs and client devices, through the embedded space and our adaptive computing, to server CPUs, to instincts and networks. So every part of our business is really contributing to a different part of the AI ecosystem. One thing that we're doing is increasingly investing more in this space. We're accelerating our Instinct GPU product to have an annual upgrade of our GPUs. And we're increasingly thinking holistically about full AI systems targeting the data center scale. So whereas traditionally AMD has been a processor company, we're now thinking about the whole AI systems, software, hardware, all the way up to data center scale, but at the same time doing it with open standards. We believe very strongly in open standards, in partnerships, in interoperability, and having open software stacks. So that part of the AMD culture is going to remain.
So what is next for both the machine learning ecosystem as well as Cerebras?
I think the truth is right now is AI has some work to do to deliver on its expectations. I think we have extraordinary hopes. We're just beginning to see this transition from training to inference. Training doesn't go away. Training remains a huge use of compute, but inference compute is a function of the number of users. It's a function of two things, really: the size of the model and the number of users and how often they use it. And so each one of those requests, each one of those prompts generates work for compute. And what we're seeing now is enterprise adoption. We're seeing really hard problems getting dropped by AI. We're seeing other hard problems that were formulated in a different manner, like search, reformulated into AI, translation, reformulated into AI, and work that computers were bad at since their invention. Understanding text, understanding images. These were not the domain for computers, right? The domain for computers were the calculations. And suddenly AI has sort of enabled the reach of compute, not just to the display of images, but to the understanding creation. And not just to the display of text, but to its understanding and its generation. And I think we got to wrap our arms around some of these and deliver value, whether it's in medicine or in drug design or in agriculture, in any number of large industries, in security and defense. That's what the next 3 to 5 years are about.
What's next for Intel? When you look at this landscape and the ecosystem developing, where do you see in industry going, but also where Intel is going to take the industry?
I mean, I think today we have a product that is really well optimized for training, fine tuning of open models, standard frameworks, and deployment, of course, right? Inferencing. I mean, we see what we've announced with Gaudi 3. We're very excited about the inferencing performance we see, right? 2x the current available solutions in terms of performance per dollar per watt. Very efficient. Really pleased with that product. We're also seeing that programmability is in our future with what we talked about with Falcon Shores. And we're going to continue to innovate and deliver solutions to customers at all levels of the stack. And our commitment to open, we announced in April the Open Platform for Enterprise AI. We've now recently launched a few services on that. So RAG, some capabilities around software development, code gen, for example. And we just see more and more services and capabilities that we need to enable through open source tools. And then at the infrastructure level, I think we'll continue to see more specialization.
Shimon, I want to thank you for the partnership because we have published now a Juniper validated design that combines our Ethernet-based solution with your solution. And hopefully that will be a good example of a proof point of where the industry is going. Lastly, I want to ask you a question about, since you have much better visibility into customers, as customers are building these large data centers, AI data centers, do you see any unique challenges they're facing that we should be aware of?
Yeah, I think there's actually massive challenges. We actually did a survey with around 1,500 organizations and ask them, what are your challenges? So some of the challenges is, how do I feed the accelerators? Another challenge is, how do I secure my data? Another challenge is actually, how do I manage my data at scale? And it's interesting because there's these challenges, but then on the other hand, we see a lot of common mistakes that are being done when designing these data centers. So for example, one of the most glaring one is that storage is, in many cases, is an afterthought. We see customers or environments saying, okay, I bought my GPUs. That's it. I have my AI data center. Oh, but I need networking. Oh, but I need storage. So it's almost like an afterthought. And then, or another thing is, let's try to use what we already have. So we invested so much in our accelerators, but let's use our old networking, or let's use our old storage. It's a pity because then you don't optimize on the investment that you did. Another common mistake is to just design for multiple different storage environments. So here's my block storage for this, here's my object storage for that, here's my NFS storage for. That's a mistake. Creating these new AI data centers requires a different approach, and technology is already at the point where it can offer this new approach, right? So you can benefit from it. And I think there is, if I would mention one or two more things, there's when you're creating these data centers, especially when we're talking about the networking aspect, actually, these data centers, organizations are now global. They're on-prem, they're on cloud, they're on private clouds, they're on multiple on-prem. Maybe I'm ingesting data in one environment, I'm training on it in another environment, I'm inferencing it back here or there. So the ability to be able to burst between different locations, to first of all have the network pipelines between these different locations, and also to have the ability to have the data platform that can send the data to different locations at scale, because everybody can move a few gigabytes, single-digit terabytes, but try to move multiple petabytes in an efficient way, that's a big challenge. So planning for that also in advance is important.
Right. Now, Shimon, that's why in this panel we have you, as well as we have people representing compute as well as GPU or AI accelerators. So I think together, to your point, if we could start creating this sort of reference designs, which are, we bring all these components together in an interoperable manner, but they're optimized, like you said, for different use cases, rather than they become afterthought. And we look forward to working with you. Really, I think this will be a good the thing for the industry to be able to bring these pieces together in a way they're optimized together rather than having to invest into any particular vertically integrated solution.
Thanks, Raj. Open ecosystems ensure an organization have flexibility and choice. It also promotes innovation and healthy competition. Bob, ecosystems are key.
Yeah, absolutely. You know, the complexity, the distributed nature of the environments today, it really requires an ecosystem. And when we say it requires, we're talking about IT requires an ecosystem.
In this new wave, ecosystems are all the rage. So the next big thing. Next, we'll hand things over to Rakesh Kumar, Senior Engineering Leader at Juniper, to talk to two industry leaders and pioneers about the best practices.
Today we are going to be discussing AI cluster technology and how it can unlock the next stage of AI adoption through powerful collaboration that democratize AI infrastructure by driving down the cost and accelerating innovation. Thank you, Adi and David, coming in today. David, tell us a little bit about you.
Yeah, it's a pleasure to be here. My name is David Cantor. I'm one of the founders and the executive director of ML Commons. We're a nonprofit and industry consortium bringing together industry, academia, and many different constituencies to make AI better for everyone, to make it faster, more efficient, and safer.
That's very interesting. And how about you, Adi?
Yeah, hey, I'm Adi Gangedi. I'm a production network engineer at Meta, and I help build and scale RDMA training and inference clusters at Meta. Meta has been building training clusters for a few years now. And I've been involved in several aspects of these clusters all the way from day one. Today, we have a large team managing these clusters, so it gives me an opportunity to focus on AI training performance, specifically from a communications and network standpoint.
Very interesting background. And David, tell us a little bit about your ML Commons, what you do, and what kind of things you have been thinking about.
Yeah, so ML Commons really got started with the ML Perf benchmarks, which is part of what's bringing us all together today. And it was sort of founded in the early days of machine learning, and we didn't have good standard ways of measuring performance. And so, we got the whole community together. We built some standard measures for AI training. So that became ML Perf training. And then over time, we've really branched out into inference, whether it's in the data center, on IoT devices, on smartphones. And really here, the goal is how do we bring together researchers, production engineers, sales, marketing, everyone on making AI more capable. And so if you're a customer, ML Perf is a great tool to figure out what should you be buying to help validate a vendor's claims. And one of the things that I'm really excited about that the team has done recently is, first of all, we've added a lot of Gen AI benchmarks. But then we also added power measurement so that you can see whether it's data center, inference, or training of these large-scale models, how much power and energy are you using? But again, it's all in service of bringing this information together and helping bring together, buyers, sellers, researchers, advanced developers, and kind of driving the community forward. And we've seen in the 5 years that we've been around, we were able to get, something like 50x better performance, which is, way faster than what we would expect. So,
thank you, David. That is very interesting, and it's amazing the kind of work you're doing. Yeah. So, Adi, tell us about that Meta and how you have been working with ML Commons.
Yeah, actually, interestingly enough, Meta was one of the founding members and has been there all along the journey of ML Commons. More recently, Meta's Llama 2, for example, actually is one of the inference and fine-tuning benchmarks as well. And in general, I think benchmarking and the work that David and ML Commons team is doing is really, really important. Because with benchmarks, you can really understand how ML models stress infrastructure or what tasks they're able to do, and you're able to reproduce them and repeat them. And if you cannot reproduce something, then it's really, really hard to improve it or to make it more reliable or so, right? So benchmarking is a very, very fundamental aspect of, what helps these, scale these clusters, things like that. And we are really committed to actually engage in ML Commons. We are active members, for example, of the Chakra work group that is focused on improving communications performance and representing the communication primitives of the AI ML models.
No, so Adi, this is really interesting, the kind of work your organization is doing and leading the effort in making this solution very scalable. This is very helpful. So David, tell me about what do you think is the next coming for ML Commons, and what do you think the kind of things you have in mind?
Yeah, so again, one of the things we spend a lot of time doing is working with, companies that are really on the cutting edge, Meta, Microsoft, Google's, all of our members help to contribute. And so one of the things that I've certainly seen is, of course, there's the explosive rise of large language models, image generators, other forms of even more computationally demanding machine learning, where we need larger and larger systems to satisfy them. And, sort of for the first time ever, we're starting to see people talk about inference using the network. Right, and like for a long time when we started out, when I led MLPerf inference, it was just a single node thing. But now these models are so big, we may not be able to do that anymore. And so, that's sort of one trend I see. The other thing is from an organizational standpoint, we're starting to look at things like end-to-end inference. So how do you incorporate things like RAG or other augmentation techniques with LLMs and other things. So, we've seen this rise in vector databases. How do we think about that? And then there's a lot of cleverness, things like mixture of experts that starts to say, hey, let's maybe de-emphasize just straight compute, and let's think about a blend of compute and networking and control that gets us to a different balance. So, those are some of the things I'm seeing, as well as, sort of a renewed push around energy efficiency, especially around next generation data centers.
David, that was very interesting background you gave, and you explained to our audience how networks play a very critical role in building a large scale infrastructure for large language model and for inference and training. So this is very important for Juniper too, because Juniper is also in the forefront of building networking product, and we want to make sure our products really work well for these kind of use cases. And Adi, I would like to understand from you what kind of things you have been doing, which you are basically bringing to the forefront to all this networking technology. You want to share your perspective?
Yeah, definitely. I think the thing that I want to echo is that network and communications are a very, very integral part of being able to run these large models or DLRM models, all of these models in like a stable fashion, but also in terms of extracting the most amount of performance out of these models and out of these clusters. So the communications stack is like really the key. And there are several things I think we are doing in terms of moving the needle here. Definitely, one of the challenges that we're trying to solve is that the DLRM models, the ranking models, the kind of traffic patterns that they produce, and the generative AI large language models, especially those ones with training, they produce different traffic patterns, and the traffic patterns produced by distributed inference that, like David just mentioned, are also slightly different. So, can we build fungible clusters for all of these use cases? Or in some cases, do we have to build specialized clusters for some of these applications, right? So that's something that we are actively looking into and trying to solve. And, as, we talked about Gen AI models, as those models scale to a very large scale, reliability becomes like very, very important. Any systematic unreliabilities in the network, or so needs to be like really, really addressed. And even after you address all of those concerns, just by the fact that you have so many links, so many switches, so many GPUs, training, it gets really tricky in terms of being able to avoid interruptions to the jobs. So if you cannot avoid it, if there is an interruption, how do we very quickly realize where the failure is and isolate it? How do we kind of get these jobs to start really fast? So if there are some initial network synchronizations that they need to do before they go on the fast path and continue training, how do we kind of reduce that synchronization time in the beginning? So those are all the things that are like very, very important from a reliability standpoint. But there are a lot of things also that we are doing in terms of making these clusters more performant. And for example, network load balancing for our Rocky clusters and our InfiniBand clusters is like fairly important, because if you cannot load balance all the traffic from the collective communication patterns produced by these ML models, then your tail latency increases. Your next training iteration is running slower, right? So you need to manage congestion, you need to manage load balancing, you need to customize the scheduling of some of these applications so that optimal infrastructure is allocated to these large models to make them performant. But yes, I think overall networking and communications are absolutely in the forefront of enabling all of these revolutions around generative AI.
This is amazing, Adi, what you told about. And we have some experience when building these AI labs, and we trained some of these large language model, and some of the things we brought out, Juniper saw all those things in our lab too. So I'm glad you are leading this effort and educating our audience in what kind of challenge and how to overcome those challenges. Thank you very much, Adi and David, for joining us today. And thank you, audience, for watching us today. Thank you.
Okay, we're back. I'm John Furrier with theCUBE, with Bob LaLiberte with theCUBE Research. We had great sessions so far. Now we're back with Praveen, who helped kick us off, and we're here with AE Natarajan from Juniper. Gents, how do you think of this program so far? What do you think of the show?
It went very well. I hope viewers are able to learn something from today's session.
Great content, amazing speakers. AE, why don't you introduce yourself to the audience and what you do at Juniper?
Thank you, John and Bob, and it's a pleasure to be here along with Praveen and the rest of you. I'm AE Natarajan, Executive Vice President at Juniper, responsible for WAN products, silicon, a whole bunch of things, and AI is the most exciting thing that I can actually talk about. Really, really a pleasure to be here.
Praveen, I want to get into the AI networking and AI native networking specifically. You launched AI native networking earlier this year. Can you give us an update and share more about what that's about?
Yeah, so first, let me reiterate, the AI native networking means when the networking products are built from ground up with AI as the core component, right? It's not an afterthought. It consists of two parts, AI for networking and networking for AI. In AI for networking, if you are familiar with our MIST technology, where AI ops was the key focus, we applied the same technology to our data center so that we can simplify the operations. On the other hand, from networking for AI, again the focus is end-to-end simplification, right? End-to-end operational simplification. And how we achieve that? Today we are coining another term called ops for AI, which consists of intent-based networking, AI optimized Ethernet, as well as AI ops. This is AI ops now applied to networking for AI. Ultimately, what we want to achieve, the utilization, the best utilization from the network, the best performance from the network, at the same time with ease of management.
Praveen, the Ops for AI announcement looks really interesting. Can you share specifically how this new announcement, Ops for AI, complements your existing portfolio?
Yeah, John, first of all, let me just clarify, right? Ops for AI, we have built a lab and we are calling it Ops for AI Lab, where customers are coming in, training their own model and figuring out that this is the performance and this is what they want to build on-prem when they go back. So also I want to tell you that when you build these clusters, there are, let's call it three types of network. There's a network where how do you go and access this cluster? There's a network which is called storage network, where GPUs are communicating to storage over this network. And then there is a backend network. The backend network is where GPUs are talking to each other. So three types of networks. Sometimes you hear the words front end and back end, but let's say predominantly there are three types of networks. Maybe I'll turn to AE to talk about how we have the breadth of portfolio to cover all this three types of networks.
Absolutely, Praveen. I'm very excited to actually talk about this because here at Juniper, we build our products with our own silicon and with commodity silicon, which gives us the flexibility to actually customize our products that can be form fit for each and every variation that we can think about, right? That is interesting. The second part which we wanted to talk about is the QFX products, which are the core center of the data center, where you actually build all the GPU clusters, connect them across with a QFX cluster in the data center. Now, Your GPU clusters are getting bigger and bigger, and you have to interconnect them now because of whether it's power, thermal, or space capacity, whatever reasons, you have to go past one building or one data center and actually interconnect them. We call this data center interconnect. And we have some exciting products that actually cater to the data center interconnect, which is our PTX portfolio of products. I'm proud to stand up here because this is the core of how we innovate here at Juniper. We were the first to release 200, 400 gig, and right now we're the first to release 800 gig. 800 gig, and this is amazing because this is an innovation where bandwidth hungry, data flow hungry, AI clusters are going to actually use that most effectively.
It's hard to mention connectivity without talking about secure connectivity. So AE, I wonder if you could address what Juniper is doing to secure these back-end networks.
Oh, thank you. Every time we talk to customers, one of the most precious things that they have is data. They want to protect their intellectual property. They want to protect their data, which is the reason when they train these models, they want to host it in a secure environment so they can train these models and make sure that these models are not getting hacked into, like Hugging Face and other things that have actually happened recently. We here at Juniper, we have a way by which we build a ubiquitous security control plane. What it does is it doesn't matter whether you use Juniper's security products, which is the SRX products, either virtual or physical products. You have a unified control plane from which you dictate the security policies.
Single policy domain.
Policy domain. It actually pushes it out to the entire domain so you know you're protected, and you're protected extremely well.
Awesome, that's great. One other thing I wanted to touch upon, Praveen, I think you mentioned earlier that Ops for AI Lab. And if I remember correctly, we talked about it at the beginning. Any chance we can give the audience a sneak peek into that environment?
Absolutely. So what we can do for today, we can roll the video because we have a pre-recorded version of the lab tour. But I do want to point out, today we are announcing that you can come visit our lab, try your model, so try and buy program, try and buy. And you will be able to see what we have done with our ecosystem partners. So it's not just about a single vendor solution across all the ecosystems, running real training workloads and showcasing how we achieve performance and scale and operational simplification with Juniper products along with the ecosystem partners. With that, please roll the video.
Juniper's Ops for AI Lab is at the forefront of innovation. We have invested millions of dollars to create the networking industry's first and only AI lab to help you accelerate your AI deployment with confidence. AI infrastructure is a new frontier for most enterprises. Our fully operational, well-equipped lab and experts are here to help. We invite enterprises and partners to confidentially test models such as Llama, BERT, DLRM, or even your own models along with your data, or use open source data sets. At Juniper, we value collaboration. We are excited to work closely with you and our ecosystem partners to deliver robust, high-performance, easy-to-deploy solutions. Additionally, you can leverage Juniper's validated design based on open, standard-based, and proven AI-optimized Ethernet infrastructure, interconnecting NVIDIA GPUs and backup storage for AI training and inference workload. See how Apstra, our data center fabric management and automation solution, simplifies orchestration. This lab also serves as the pivotal environment for testing ML Commons submission, reinforcing our commitment to advancing AI technologies and industry standards. AI data center infrastructure doesn't have to be a mystery. At Juniper, we are committed to democratizing AI. We can guide you through designing, deploying, and operating AI infrastructure.
Wow, that's great stuff. Love that lab. This is like Excellence Center. This is where you guys are doing some great work. Congratulations on that sneak peek. Got a good look at ourselves here with theCUBE Inside Edition. Thanks for doing that.
Thank you. Thank you, John. Thank you, Bob.
Thank you, John.
Guys, congratulations. 800 gig, you're feeding those starving AI workloads. Good stuff, and open, love that. Congratulations.
Just kind of run through and summarize what has been kind of discussed so far. So artificial intelligence or AI has been, has not received a lot of, I would say, headlines until very recently, when OpenAI released ChatGPT, right, back in November 2022. Prior to that, AI ML has been very much, in either in academia, in research, or it's being used by large companies at the back end, and we don't deal with it directly in a sense, right? So, companies like Spotify, Netflix, Amazon has been using AI ML for years to they use actually a model called a recommender systems to predict what kind of either movies that you will like, what kind of songs that you will like, and what kind of products you may want to buy from Amazon, for example. All these are actually done by algorithms and models using recommender systems, right? So it's just that we don't interact with it directly, but with the ChatGPT being released after that, it's the first time that we kind of interact directly with AI, so to speak, right? So that is kind of very much changed the game. So and what has made all those very powerful capabilities and models possible is basically due to three factors. Firstly, of course, is the availability of large amounts of data. We've created tons and petabytes of data out there in the internet, and all those data can be used to train AI models, right, to be able to predict. So at the end of the day, what you want out of AI or ML is basically to predict, like to do prediction or inference, right? So and the second reason is because of compute, right? So with I wouldn't say it's cheaper, but availability of large quantities of compute, GPUs right now in particular, and then that gives rise to the ability to run large, what you call deep learning models, like deep neural networks, to be able to do some of the very powerful things that you see today with machine learning, right? I like to kind of demonstrate, or not demonstrate, but to kind of illustrate, I should say, some of the capabilities of what some of deep learning can do, neural networks, right? So there's this very famous kind of a news headline sometime back in 2016 March, I think. This very famous called Move 37. So AlphaGo from a company called DeepMind, which has been acquired by Google, and what they came up with was algorithm machine learning to play this game of Go. Okay, Go as in Go, right? So it's, as you can see, it's basically white and black palettes that you used to play, and this is considered to be one of the most complex games, for any computer algorithms to be able to play well, and not just play well, but to win even, right? But AlphaGo was trained, using neural networks, reinforcement learning, and some of these algorithms, and it played against itself, and to the level that it can actually beat this very famous Go player champion called Lee Sedol, right? So that was in 2016, and there was this particular move that shocked everybody. It's called Move 37, where the computer actually made this move that was totally unexpected, even among all the Go experts, and everybody that was watching it kind of didn't expect that. So it was something that brought on a new era of what AI can actually do. So we talk about the session mentioned quite a few topics, but I just want to highlight and reinforce some of these topics, right, and messages. The first, of course, Very often for the GPU back-end cluster, you hear about the different networks, front-end, back-end GPU cluster, and the back-end storage. And the back-end GPU cluster network, typically where you connect all the GPUs together for doing training, very often is InfiniBand, right? So and NVIDIA typically kind of recommends or pushes InfiniBand. But what the rest of the industry is saying is that Ethernet can actually do just as good a job, if not even sometimes a better job from different aspects. So for example, ACG Research has a report that says that the 3-year TCO for InfiniBand over Ethernet can be even higher than Ethernet, right? Another consideration to be things like obviously InfiniBand is only offered by NVIDIA with their acquisition of this company called Mellanox. Mellanox was the only company in the world that provides InfiniBand. And of course, the other one is skill set, right? So to find skills that is capable to manage and operate Ethernet networks, it kind of is almost universal. But you're going to find someone who's able to work with InfiniBand, is probably very, very rare skill, right? So that will some of the considerations and drive up costs as well, right? And then we talk also about the ecosystem. Again, AI ML is such a huge, large, and complex kind of technology and development that it's going to take more than just one single company to be able to provide for the whole stack and provide the full solution, right? This is a good example where ecosystem partners and players come into play to provide the best of breed, as you heard from the video early on, right? So of course, from the semiconductor level, people like NVIDIA, not just NVIDIA, but Intel, AMD are also coming up with their own GPUs. And also you heard from Cerebras. Cerebras is a new startup, and what they do is their chipset is basically focused solely for AI training, right? So and initial reports from their chips found that they are even better than NVIDIA's chips like H100s, right? So a very interesting development, and there will be even more small companies and startups like this that actually kind of specialize their chips just to do AI ML training, right? And from a compute end, these are not exhaustive list. There's a whole lot of players in here. I just name a few: Supermicro, Dell, Lambda, and of course you have people on HPE who provides the servers, ASUS, Gigabyte, lots of other compute platforms that provides these kind of servers for doing AI training and as well as inference. And then of course the other big piece that should not be forgotten is storage, right? Whether it's from Weka, Pure Storage, or Dell Storage. So again, you can see there are many layers, many components, many moving parts, and this is where I think the ecosystem plays a very critical role in providing the infrastructure for AI. And I think there's nothing more powerful than actually, being able to show to customers and to the world that Ethernet can actually do the job, right? So again, you saw the session with Praveen and AE talk about the ops for AI, and we have this AI lab in Sunnyvale that is fully decked out with GPUs of a combination of H100s and A100 GPUs. Total 96 GPUs in the setup, and we're looking to also expand it as well. And as you can see, it's a relatively complex network, and what we did was we actually ran model training, BERT large in this case, Llama 2 Nemo, the Nematron models, instruct models from Hugging Face that we downloaded, and we run some of these training, and we will see that the timing, the important things, that what we call the job completion time. It means the amount of time to run the number of training cycles, right? We call epochs, as you run these models, the training iterations, right? So how long it takes to complete, the number of epochs, and you can see that based on timing from Ethernet as well as InfiniBand, they're very comparable, right? In fact, in some cases, potentially even better. But I think the key thing is that running in terms of performance, able to run and support this kind of workloads is one thing, but I think managing it and having visibility, it's it's something that is even more important. Right? So in this case, Praveen mentioned Ops for AI. Right? So we have a product, or we have a software called Abstra that gives you full visibility into what's going on in some of these in the back end GPU training network. Right? So again, just to take note, and again, this AI lab is available for any of our customers who wants to either see for themselves that this actually works. And personally, I've actually worked with the lab for some customers in Asia, where we actually do a demo on them for them, and I think the feedback has been very positive. And they say that the feedback from customers that wow, we didn't expect that Ethernet can actually do the job as well as InfiniBand. So again, if you do have any such requirements, reach out to your local Juniper team, and we can always arrange for either a physical session, if possible, that you visit the lab, or not, we can definitely do over a web session. That can be arranged very easily. So again, just to mention, Ops for AI, it's been Juniper's aspiration as well as mission to make sure that AI ML training and workloads are democratized in terms of cost, in terms of capability, and that there's industry standard support, right, through all these ecosystem players. Okay. So right now, I would just want to see if there's any questions from the chat. Let's see. Oops. Yeah. Let me see if there's any. Okay. We've got a couple of questions. So someone asked about Juniper Mist AI. What is it used for? Thanks for the question, Prakash. So, and also, again, thanks for bringing up. For Juniper, in Juniper, we got into AI not by it's like some companies they just make a claim to say that we support AI. So when Juniper acquired this company called Mist, is a for those who have not heard of it, but hopefully most of you would have heard of it. It's a Wi-Fi company. But what was interesting with the acquisition was we were eyeing the AI capability behind Mist, right? So and Mist has been using some of the AI ML models to train their models to be able to do things like radio resource management capabilities, to do things like what are some of the potential issues, placement of APs, where are the issues in terms of back reception, back connectivity, and things like that, right? So they've been doing this for a while, right? And what we've done is that when we've acquired them, we've acquired this technology as well. So that's why, as Praveen mentioned, when we say AI native, it means that this is actually built into the product. It's not something that we just kind of add on, right? So, and we are extending the AI capability to all the other domains, like the data center, as well as in our WAN, right? So for Juniper Mist, the AI is actually used for managing networks, right? So it's called AI Ops or AI for networking, meaning you leveraging AI for networking, which is AI Ops, all right? But today's session is about networking for AI, right? So that means building networks and network infrastructure to support AI workloads, right? So that's why it's networking for AI, which is today's session. Okay. So I think, I think there are a couple other questions here, which I'm not too sure. Maybe we'll reach out to Prakash separately in terms of coding language and software that Juniper users may. Yeah. So anyway, Prakash, if you are still there, we will reach out to you to better understand what actually you're referring to. Right. So we have still a bit of time to see if there are any more questions from anyone. Please feel free to use the Q&A box, Q&A, and then you ask any questions that you have pertaining to the session, the various discussions earlier on, or even you have any specific questions regards to some of the AI ML models or training. You can feel free to ask as well. So we still have a bit of time for that. Any other questions? Please use the Q&A box. Okay. Looks like there's no questions for now. In that case, then let me just kind of wrap up. Let me share the final slide. Okay. If you are not comfortable, no problem. You can reach out to your local Juniper, sales or SE team in your country if you have no specific questions. And we will try and get those answers to you. Right. So in closing, I think for all of us, especially in this technology field, this technology area, we cannot kind of deny or ignore what's going on around us, right? So an AI ML is really development and trend that is only going to grow, exponentially, right, in terms of what it can do and the benefits, right? So for many customers that I know of, if you think about it, AI ML, there's a lot of applications from a business point of view, right? So like I mentioned, companies, you don't even have to be large companies like Netflix, Spotify, any companies, as long as you're selling a product or you're selling some services, or if you want to prevent churn of customers, you could be in banking, manufacturing, government, logistics. In fact, any industry has the potential to realize huge business benefits with AI, ML applications and algorithms, right? So this is something, if your company, for example, is thinking about it, great. If your company has not started to think about it, maybe it's a good time to approach your leadership team or your business leaders in your company to start looking into how they can deploy some of these AI ML applications, right? Or models. So developments and investment is continuing, especially as I mentioned with the release of ChatGPT. So ChatGPT is a new category of AI models we call generative AI or Gen AI, where the model can generate stuff, right? Generate things, right? So previously, models don't really generate. You can do translation, you can do recommendation, you can identify or classify. The term is classify whether a picture is a dog or has a cat in it. You can make some of these decisions, but in terms of generating almost like new content, like what a human can do, is something very new and it's only going to grow, right? So generative AI, and now it's not just text, right? So if you use ChatGPT, you use Claude, you use Meta AI's Llama, you key in some prompts, and what the model comes up with, you give you a whole text of answers and responses, right? So now you have not just text to text, but text to even images, like you can create images, text to videos. Right now, people or companies are releasing models that you can key in some prompts and it can generate realistic, right? Not just cartoonish animated movies, but actual realist, hyper realistic movies, right? So right now they are very short clips, but again, there's a huge potential to grow in that area. And the last area of development that's going to be also going to grow exponentially is in the area of robotics, right? Some people call this physical AI, meaning AI actually inheriting a physical form in the form of a robot, right? And again, huge progress is being made in those areas. The third thing is tools and models are also getting a lot easier to use. Today there are even GUI graphical tools that you can use to run models and to test out different models, which is the model most suitable for your use case, for your business case, depending on what you want to do. The fourth point, which is very important, that I want to emphasize, that Juniper is really well positioned to help you with your AI infrastructure journey. We have partnered with, as you saw earlier on, with storage companies like Weka. We partner with, some of the, like even with, Intel, AMD, NVIDIA, Cerebras, some of these people, and of course with Supermicro and some of these compute vendors as well, like to come together to help you with your infrastructure requirements for AI ML requirements, right? And then finally, as a closing, make it your personal, how should I say, kind of journey or aspiration to learn more about AI ML, right? So AI ML is really something that's, if you have the knowledge, you have this, even the skills, if possible, you really be well, positioned for you as either professionally or personally, for your future, right? So again, there are lots of resources out there. Just search anywhere in the internet, Google it. Tons of videos on YouTube about AI ML. So, and a lot of courses as well you can take. Some of them are free, some of them are paid. But do kind of as a personal encouragement, do go and pick up some of this knowledge yourself. Thank you for joining us in this session. Hopefully this again has been useful in helping you understand some of the possibilities, where to start looking, or even if it helps you to start thinking about who you can approach when your company decides. It's not a matter of if, in fact, it's a matter of when your company decides to embark on on an AI ML journey. Right? So again, do reach out to us. We are very happy to help, and we have all the resources and the knowledge there as well. All right. So with that, thank you so much for staying through this whole almost 90-minute session. Wish you all the best. Have a good day ahead. All right. Thank you.